Welcome back, everyone, to day 54 of our journey. So we've spent a ton of time learning how to construct, build, and deploy our code, right? But today's explainer shifts our focus to something arguably even more critical, actually securing that code. Today, we're going to completely demystify the world of DevSecOps. Because let's face it, it's no longer enough to just build things fast. We literally have to build them safe. And today, we're taking those high-level security concepts and translating them into tangible, automated realities.
Here's our roadmap for today's explainer. We'll start with a quick welcome to day 54, then break down the core security scans. After that, we'll equip our DevSecOps tool belt, and finally, we'll bring it all together in the Secure Pipeline project.
All right, let's dive right into section 1. Welcome to day 54 and an introduction to Secure CI/CD.
So what exactly is Secure CI/CD? Basically, it's all about integrating continuous security checks directly into your continuous integration and continuous deployment pipeline. This is the mindset shift that drives literally everything else we're going to talk about today. I want you to think of your deployment pipeline like a massive international airport. In the old days of software development, security was basically just a guy at the boarding gate doing a quick glance at your ticket right before you got on the plane. It was an afterthought, a huge bottleneck, and honestly, usually way too late to catch anything malicious. Secure CI/CD completely changes that whole paradigm. It's the entire overarching security framework of the airport. We're talking metal detectors, baggage scanners, and passport checks at multiple, continuous stages along the journey. We want to ensure that absolutely nothing dangerous, no vulnerabilities, no bad code, no exposed data, is allowed to board the plane and make it into our production environment.
Moving right along to section 2, the core security scans. Think of these as the TSA checkpoints for your code.
First up, we've got SAST, which stands for Static Application Security Testing. And SAST is incredibly powerful, mainly because it analyzes your source code for vulnerabilities completely at rest. It doesn't even need to execute the program. Think of SAST as a highly trained security guard who sits down and meticulously examines the raw architectural blueprint of your code before anything is actually built, compiled, or run. Because it's looking at that raw code, it catches fundamental structural flaws incredibly early in the development lifecycle. If a developer accidentally writes a function that's inherently vulnerable to, say, an injection attack, SAST is the mechanism that throws a massive red flag before that code ever even leaves their workstation. Next up, we shift gears to DAST, or Dynamic Application Security Testing. So where SAST looks at the blueprint, DAST shifts our focus entirely. It tests the application while it's actually running and interacting with its environment. This is basically your active penetration testing phase within the pipeline. You see, DAST doesn't really know or even care about the underlying source code. Instead, it looks at the running application from the outside, exactly like a malicious hacker would. It starts poking and prodding the live app, sending weird, unexpected inputs, trying to bypass authentication, and just seeing how the system reacts in real time. It's an absolutely vital layer because some vulnerabilities only reveal themselves when all the different pieces of your application are finally stitched together and running on a live server.
Finally, we have secret scanning. Now, this is a very specific but absolutely crucial automated check. Secret scanning detects exposed passwords, authentication tokens, or API keys that have been accidentally hard-coded or hidden right there in the source code. Going back to our airport analogy for a second, secret scanning ensures you haven't accidentally left your sensitive house keys or passwords sitting in your checked luggage as it goes through the pipeline. And believe me, it happens way more often than developers like to admit. Just one quick copy-paste error, and suddenly your highly sensitive cloud provider access keys are pushed into a public source code repository. Yikes. Secret scanning acts as that final safety net to catch those highly sensitive strings before they're ever committed and potentially exposed to the whole world.
Okay, so what is the crucial difference between these two main methodologies? To recap, SAST examines the code at rest, while DAST examines the application while it's actually running. Honestly, the absolute best way to remember how these interact is with a quick culinary analogy. SAST, it's like reading through a recipe to see if someone accidentally wrote down poison instead of sugar. You catch the massive error before you even turn on the oven. DAST, on the other hand, is waiting until the cake is fully baked, taking a big bite, and seeing if it makes you sick. You absolutely need both, right? The recipe check catches the obvious structural errors early on, while the taste test ensures that the final assembled product operating in the real world is actually safe for consumption. Together, they create a seriously robust defense. All right, let's get into section 3, the DevSecOps tool belt, featuring GitHub Actions, Trivy, and SonarQube. So here is our specialized tool belt for day 54. We've got 3 main components that perfectly map to the theories we just broke down. First up is GitHub Actions. Now, this isn't a security scanner itself. Actually, it's the automated engine. It's the literal conveyor belt moving our code through the airport. Next, we have Trivy. Trivy is a super comprehensive security scanner, and we're going to use it specifically to hunt down vulnerabilities in our dependencies and handle all our secret scanning. And finally, we've got SonarQube. SonarQube is an incredibly powerful platform that analyzes your overall code quality and executes our SAST, our static analysis. It's the tool that's going to be reading our recipe to find those structural flaws.
Which brings us perfectly to section 4, the Secure Pipeline Project. It's time to bring it all together.
Our ultimate goal for today's syllabus is constructing a complete secure DevSecOps pipeline. We are taking all those core security scans we just talked about and mapping them directly into an automated workflow. And you know, the real beauty of DevSecOps is that the developer shouldn't have to remember to run these tools manually. The security is baked directly into the everyday process of committing and pushing code. If the code is bad, the pipeline breaks, and that code never reaches production. It's a brilliant, self-enforcing security mechanism.
Let's walk through the exact chronological flow of how our project operates. Step 1, a developer makes a code commit, pushing their brand new work right into the repository. Step 2, that simple, everyday action immediately triggers our GitHub Actions workflow. The conveyor belt turns on. Step 3, GitHub Actions automatically fires up SonarQube. SonarQube pulls the code and runs our SAST, meticulously inspecting the blueprint for any static vulnerabilities. Then, step 4, either simultaneously or right after, Trivy jumps into action, running a deep scan for any exposed secrets, passwords, or vulnerable dependencies. The best part? All of this happens in literally minutes, providing instant actionable feedback to the developer. If any of these tools find a critical issue, the pipeline stops dead in its tracks. The plane does not take off.
By successfully combining all these concepts and configuring these tools, you have completed the blueprint and built a fully functional, enterprise-grade, secure DevSecOps pipeline. Think about what we just did. You've achieved secure CI/CD. You've implemented the core principles of SAST and DAST. You've enabled that vital secret scanning. And you've gained hands-on experience getting GitHub Actions, Trivy, and SonarQube to work together in perfect harmony. You have literally transformed security from a manual bottleneck into an automated enabler.
You've successfully diffused the ticking time bomb of insecure code. For now, at least. Your infrastructure is solid and your pipeline is acting as a relentless, automated security guard. But I want to leave you with this one thought as we wrap up today's explainer. The cybersecurity landscape never, ever sleeps. Security is a continuous journey. It's not a final destination. Sure, your pipeline is secure today against today's known vulnerabilities, but what new threats, 0 days, and complex challenges is day 55 going to bring? Keep that curiosity alive, keep refining those pipelines, and I will see you in the next one.